Thanks everyone for coming to our Cybersecurity Symposium. My name is Joshua Jacobson. If you haven't gotten any of our complimentary ice cream, be sure to enjoy some of that at one of our breaks. If you don't see it around, go ahead and talk to Ethan Martin. He's in the orange shirt there in the back. He might say something to the effect of, "What are you talking about? We don't have free ice cream." But that's just because there's a limited supply and you have to be really persistent. So just keep talking with him and I'm sure he'll find some. But I'd like to talk to you today not about ice cream and about our Dynics cybersecurity console, also known as ICS360.DCC. This is a single pane of glass that we use to manage a number of our different ICS products, both the ICS360 Defender and ICS360 IAM. I'll give a quick overview of what those products are and how DCC works with them. And then we can go into a little bit about what we've changed and how we are looking to move forward in the future. All right, so as you may be aware, our ICS360 Defender product is an industrial firewall that is capable, among a whole range of other things, of managing network traffic, helping you perform some network segmentation, allow authorized user access, and a number of different things. And ICS360.DCC is able to assist in that process by allowing you to manage a whole fleet of ICS defenders. You can define rules, aliases, rule sets, a number of different things that can be deployed out to those ICS defenders, and those can become your policy for your entire network. In addition, ICS360 IAM is our identity access management product. You'll be hearing more about both of these later today, of course, but IAM is able to control access to a given endpoint using some user authentication, and you can use DCC as the source for those users. So you can manage a whole fleet of IAM instances across your network and have a single point where that authentication happens. So I'd like to get into a little bit more about what we've been doing with these products over the past year or so. And the first thing that's come up has been rule priority and ordering. So this has been something that we were intending to put in kind of in the initial release of this product, but it got bumped down a little bit. We'll talk a little bit more later, but this is allowing you to define execution order of your policies and which rules get solved first and those sorts of things. In addition, we've implemented some functionality to clone rule sets and aliases. Now it's easier than ever before to define rules, aliases, all of the pieces you need in DCC. And we've actually switched to using network-based rules. And I think most of you are probably thinking, what the heck is a network-based rule? Don't worry, we'll get to that. That'll probably be the brunt of the presentation today. And two things that I won't be showing directly today, but you can definitely get a feel for if you're playing with our DCC instance here today, or if you get one set up on your own network, are our improved integration with ICS360 IAM and our kind of numerous performance and reliability improvements. So these two things are obviously not something I can show, but it's definitely something you get a feel for when you have it in your hands. So let's talk a little bit about rule priority. As you can see, these two rule sets are made up of the same constituent rules, one to allow TCP traffic, one to allow ICMP pings, and one that blocks any other access. You might have a similar rule set on your ICS defenders as they stand now. But in this case, the rule order matters, right? We solve the rules as a first come, first serve basis. So in the case of the first rule set, you can see that both TCP and ICMP traffic would be allowed because they're before the block rule. And in the case of the second rule set, the block rule is actually coming before the ICMP rule, so ICMP traffic would not be allowed when you deploy that up to an ICS defender. So we've just added this convenient little order view to be able to switch your rules around within DCC before you end up deploying them to your ICS defenders. In addition, if you had some existing rules in DCC that you were interested in getting to other ICS defenders, the simplest way is already a part of DCC. You're able to just add more ICS defenders to those collections and those groups and deploy out to those. But if you wanted to create a separate rule set, for example, to segregate some portion of your rules to just a subset of defenders, or you wanted to have similar but separate policies for different environments, you're able to now just quickly and easily clone rules, rule sets, aliases, just about any piece of our firewall components to another instance. So let's talk a little bit about network-based rules, that idea that I had kind of mentioned earlier. And we're going to actually start up by backing up a touch and just talking about regular firewall rules and why do we kind of define rules the way we do. So let's say I've got an ICS Defender here, and that's uplinked to a plant-wide network that kind of spans across my entire factory floor. And below this ICS Defender, I have a switch and a number of different devices, PLCs, HMIs, etc. Typically, that's just 2 Ethernet cables plugged in. We call one WAN, we call one LAN, we write some firewall rules for them. And usually that just comes in a really simple GUI like this, right? We define some rules. We say that this should apply on ingress to the WAN interface or the LAN interface, and we define a set of policy like that. And if that's how firewalls work for you, and that's how you like to visualize these sorts of things, great. That will continue to work in ICS Defender, and we still have support for that in DCC. But things get a little bit more complicated when, instead of talking about one isolated environment, we're trying to determine policy for a whole bunch of different ICS Defenders. So let's say, instead of having one ICS Defender, for the sake of your plant floor security and Chris's commission, you have a whole bunch of ICS Defenders. The idea here is what we're trying to do is isolate these environments from talking to each other and deploy kind of a standard rule set amongst them. But what are we really trying to accomplish here, right? It's not we want a specific firewall rule on different ICS Defenders. We would really rather prefer that we have one isolated network up here and several isolated networks downstream of the ICS Defenders. We want to segment this network and be able to protect the traffic that flows between them. And in this case, we thought that it was going to be easier within DCC to be able to manage the rules on these ICS Defenders by first defining what our networks are and then applying rules to them. So if I go ahead into this next slide here, we can see how this looks in DCC. We have a networks page where you get to go ahead and determine what interfaces on what ICS Defenders are connected to what network, right? And we can do this pretty easily with network names, right? So if you've named your interfaces plant floor or WAN or something like that, we can determine that. But we also have the capability to determine it by what IP address is on that interface. And so let's say if I'd gone back to this previous slide here where I've got all these ICS Defenders, maybe I set up the first 3 and I'm lazy, so I just called them WAN and LAN interfaces. But maybe Ethan sets up the next 2 and he's a little bit more professional with it and he calls it plant floor and controls network. And then maybe Kyle sets up the last one and in his haste, he accidentally forgets the A in the network name, right? To make it a little bit easier to kind of bring all those together and say, okay, well, I really want this to all be applied consistently to all of these ICS Defenders. We can just say, okay, if the interface name is plant floor or WAN, or we've got an IP address that's in this subnet, really that interface should be as a part of this network. So you've got a lot of customizability here to be able to determine, what networks contain what interfaces, and then we can go ahead and use those networks to actually create a rule that allows or blocks traffic on one of those networks. So in this case, I just say plant floor. DCC is going to go ahead behind the scenes and figure out what ICS Defenders and what interfaces on those ICS Defenders actually need to have this rule. I've got a real easy way to just create this and say, okay, this is the network that it should apply to. If we go back and look at this diagram here, we can see that in this case, based on the network that we've already defined and the rule that we put on that would end up on one interface on all of these ICS Defenders because they're a part of that LAN network. I think this has a couple upsides. It means you have less duplicates for different interface names, different ICS Defender configurations. Maybe you've got different platforms. Some of those are nanos, some of those are minis. You can define your networks in DCC and have a real simple time actually going to deploy those. And it's easier to start DCC in some legacy environments. If you've got brownfield ICS defenders that are already out there, you might be adding some new ones in. This makes it a lot easier to kind of integrate with multiple kind of complex configurations that you might already have out there. And in addition, if we go back to this slide, it's a real easy way to say to someone, like, this is our policy enterprise-wide, that this is the rule set that we have for this plant floor network. You don't have to give the implementation details of it's the plant floor network here, but it's you know, a different name over in this facility, and it's a different subnet over here. You can define those networks and make your rule configuration really simple. So with that, I'd like to talk about kind of the future of DCC and where we'd like the product to go. And of course, we're always looking for feedback. Go ahead, Jeff.
I have a question.
Yeah.
So what you've basically said is that even though each ICS defender still does interfaces the way they've always done it, when you define it as a network in DCC, it makes the appropriate translations in the background when applying those rules and interfaces to those individual ICS defenders. So the defender still works, thinks, looks the same as it always has. There's nothing new to learn there. But DCC just has the automation and the intelligence to map your network to everywhere that it's appropriate.
Exactly. Yep. We had two goals going into this. We wanted to make it as easy as possible to keep existing ICS defender configurations out. We didn't want to have people go ahead and change all sorts of ICS defenders just to get them to work with DCC. So we keep the interfaces the same, and we wanted to make creating rules as simple as possible, right? I just wanted to define one or more networks that this rule should apply to. I don't want to have to think when I'm creating the rules what interfaces and what the actual configurations of all my ICS defenders look like. I want DCC to be able to be smart enough to say, this is the network definition, what interfaces should be there, and I want to be able to get a list of what interfaces are out there and what rules would be applied to. So with my last couple minutes here, I'd just like to talk a little bit about where we're going forward in the future. And once again, if you have any ideas, feel free to ask a question or come talk to me later. We're still continuing to expand features on DCC, make it even better. And a couple of those ideas that we're going through, some of these are already in development, some of these are planned for the next couple months, but we're looking to support firmware and package updates through DCC. This would allow your ICS defenders to talk to DCC for all of their updated information, and then you only have to punch one hole in your firewall to reach out to our cloud infrastructure for ICS defender updates. It's only coming through one spot. You can have that audited and done securely, and then it's through an encrypted pipe to all of your ICS defenders. In addition, we're looking to import rules from existing defenders. Say you've already got a standard configuration out there on a lot of your defenders, and you just want to import that into DCC and have DCC start managing that instead of a bunch of individual ICS defenders. That support is going to be coming pretty soon here down the road. We're also looking at LDAP, Active Directory support. So in DCC, to be able to manage users there, that functionality would allow those to be worked in with your existing solution as opposed to kind of bespoke users in DCC. And finally, deployment previews. So you can actually see what rules and what changes are going to be made to each ICS defender when you're doing a deployment from within DCC. With that, I think I'm probably pretty short on time, but I'd love to take any more questions if anyone has any. Otherwise, feel free to find me anytime today, and I'd be happy to talk about DCC, ICS Defender, anything like that. Thank you all for your time. I'm going to turn it over to Kyle here in just a sec for a demo.
All right, so thank you, Josh, for that lovely introduction to some of DCC's new features that we've gotten over the last year. My name is Kyle Leash. I'm a software engineer here at Dynics, and I am going to walk you through some of the changes that we made to DCC here in the last year, but actually in practice. If you're anything like me, you're going to find it a little bit easier to see that on a regular schedule or on a regular usage in production, perhaps. If I can get my screen right here, it looks like we're good. If I can share that real quick. Oh, sorry, I gotta take this real quick. Hello? A network intrusion. All right, in plant 1, All right, you investigate, I'll quarantine. All right, so I was gonna try to work you guys through some of the different ways that DCC had changed, but if you're gonna have to bear with me, I'm gonna have to make some on-the-fly changes to one of my networks. Let me minimize this right here real quick. And I'm gonna have to walk through a quarantine of plant 1. Now, I have set up a specific rule set to do this in advance. By applying this lockdown rule set to my plant 1 network, I'm going to be able to quarantine all of the different network traffic that may be coming off of that network, essentially isolating this network intrusion at its source. So now that I've gone ahead and applied that lockdown to this plant rule set, I can now go over and deploy it on DCC. Or can I? A question that you might have that you might ask is how exactly I know that that lockdown rule is going to be put at the highest level of priority. How I know that it's going to block all of the different rule sets and rules that I've already put in place in my network infrastructure. Well, that's a great question. If I come into my plant 1 network, you can see that I've got the list of everything that's in this collection. And we've actually introduced a new view in this recently over the last year, and that can be found at the very top of the screen by switching over to my order view. Now, just like an ICS Defender, this lockdown view is in the bottom when it's added, and thus it wouldn't block the traffic that I needed to block in this situation. But using a simple drag and drop interface, I can move this lockdown to the very top, making it the highest level of priority when I know that I need it deployed now. So if I save this and go to my firewalls page, I can hit deploy and deploy to plant 1. And just like that, we can see that my network intrusion has been blocked. But how do I know that that's not blocking all of my network traffic? Obviously, I don't want to bring down my plant floor for too long. That would be detrimental to to production overall. So we're going to have to make sure that that gets a little bit more refined over time. While we wait for the network engineers to really figure out how we can scope that down, I'm going to show you some of the different ways that the UI has been improved within DCC in the last year, just so that you can see some of the ways that you're able to more streamline your usage of DCC. Now, if you noticed before, the actual usage of the collection screen has been changed. Before, we would see this grid view, which is more in kind with what you've seen in the last year, but yes. So you can see this grid view, which is what it used to look like more, but I actually had it on the table view earlier. And that allows you to get a little bit more refined and compact data so that you're able to see more at once, and also get a pretty easy way to see in a familiar format all the details about your network. And then we've also added a variety of different filters to our different areas. And I think that this is most helpful really in the devices screen. For instance, if I wanted to see all of my offline ICS defenders, I can go to my connection status and hit not connected. And that would filter it to all of the ICS defenders that haven't been connected. And similarly, if I wanted to find just a factory 1 defender, I can search, if I spell it correctly, you can see that I can narrow that down very easily and get the data that I need as soon as I need it. And I just got some more information from my network engineer. We've figured out that the device that's been causing the intrusion is actually a newer device that we added to our network. And to do that, to quarantine that a little further, I can go and add this to my blocked hosts, which is something that I've set up a little bit in advance for a situation like this. If I go to my firewalls, I can go to my aliases tab, and then you'll see that I have a blocked alias. If I go into that blocked alias, you'll see that it has a couple of different hosts that we don't allow traffic to go out of in our network. And we want to add this new infected device to make sure that its network traffic is completely cut off. Now, I could do that by retyping in all of the details about the device and the IP address and all that. Or, since I know that it's on the same network as these other blocked hosts, I can use the new clone feature in DCC. and hit this target alias is the same by default. And you can see that this brings up a clone of this alias item. With the clone, I can simply rename it to the infected device. And I can now just change the IP address without having to remember all of the complex information and re-enter that in a different area. Now, since we've added that to our blocked hosts alias, we could go ahead and deploy that to our plant floor as well. But first, let's allow some of the more restrictive network rules to go off. Now, as you can see here, we've got these various rule sets, and like the one that we added for the lockdown, which we can now remove. You can see now if I go back to my order view, that the blocked hosts and the interfactory connections, those rule sets are now at a lower level. And if I refresh that page, you'll see that that lockdown rule set is no longer being resolved in the deployment order. So now that I know that the infected device is blocked from the network and that all of the deployment is ready to go, I can head back to the deployment screen and deploy to Factory 1. And now I've made it so that we've cut off access by that infected device and not the entire network overall. But that's not all I've done. In fact, this device that's infected is also found on our Factory 2 network. And instead of having to go to that ICS Defender and reintroduce all of the same IPs and rules, I have made it so that the rule sets apply to the Factory 2 as well. So I can now deploy to Factory 2, and the device that was compromised in Plant 1 is now also protected in Plant 2 without any additional work on an ICS Defender from the perspective of that factory. Now I know what you're thinking. It can't be that easy to simply implement those kind of rules. And I would say if it was just those plants, it actually is pretty easy like that. But for the sake of this network, we actually do have one other thing to do. We recently introduced a new ICS Defender network in our sandbox network. And that sandbox network is a way that our engineers can actually go through and test some of the infrastructure before it's out. So I don't have that in my deployments here yet, but I would like to extend it so that we are able to use that ICS Defender with and protect it from this network intrusion as well. If I go over to that ICS Defender, which I had pulled up here, I can log into it and go to my system DCC integration page. And you'll see here it asks for an adoption file. If I go to my Dynics Cybersecurity console and go to devices, we have a very convenient Adopt New Devices tab. And if I simply select the network interface, which is my Ethernet 4 in this case, you'll see that I'm able to generate a new adoption file. And then I can go to my ICS Defender again and simply upload that file to adopt it to the cybersecurity console. And now if I come back to my cybersecurity console, you'll see in a moment that we now have a brand new ICS Defender that's already been adopted and is ready to use with our existing infrastructure with DCC. Now, while I'm in this screen, I can show you a couple of different information tidbits that we have that are brought along when you adopt an ICS Defender. As you can see, it's got all the network information along with the MAC address, device IDs, but we also have some more complex backups and such that we can show you various different backups that have been received, and that includes when we make deployments as well. And then in addition, we also talked about asset management earlier in the conference. You can see you can also see which devices your ICS Defender can really get access to with that detection from DCC itself, making it so you don't have to log into the ICS Defender to see those different assets that might be detected. Now, I want to defend this defender from that network intrusion, and let's do that. By coming over to my collection screen, I can hit New Collection, and I can do it as my sandbox connection. And if I add my sandbox, my ICS Defender that I just added from the sandbox, and then add the lockdown rule set, or the blocked host rule set as well, you'll see that I get this error that says the rule set doesn't have all interfaces owned by the defender. And that's because in this specific instance, our sandbox ICS Defender is configured a little differently from the other ones. And in this case, we've renamed the LAN network to the sandbox network. And that's basically to ensure that our network engineers don't push anything to production that they don't intend to. Now, in most scenarios, I'd have to remake a rule. I'd have to go in and basically change all of the different configurations to suit this tiny change in our ICS Defender configuration. But with the new networks feature, I can come through and go to Firewalls, Networks. And if I go to my LAN network, I can simply add a new network name, which I know is Sandbox for this ICS Defender. And if I save the changes and refresh the page, and simply go back to that network screen, you'll see that now instead of having two ICS Defenders in this interfaces tab, we actually have three, and it matches the sandbox interface to my current existing LAN sandbox, or my LAN networks. So now if I go back and re-add that connection to my collection for the sandbox, I can add the blocked hosts rule set. And you can see we successfully added that rule set this time. And now I can go over to my deployment screen and hit deploy on the sandbox connection rule set. And after a brief moment, that brand new ICS Defender, which we had never introduced into DCC and had different network configuration and various differences from our other networks, has now been deployed and is protected from that network vulnerability. Just as simple as that. So with that, that's a brief overview of some of the different features and such that we've brought to the ICS Defender in coupling with the Cybersecurity Council. And it's made it simpler than ever to really respond to the various needs that you need to do in your factory, especially when time matters. Thanks.